Hello everyone. Welcome to our session on AI-enabled autonomous data centers. My name is Sanjay Sainani. I'm the SVP and CTO at Huawei Technologies for our global data center business. We are living in interesting times. I'm currently recording this session, which will be presented to you via video link. I'm sure many of you will be participating via an online session. We are in the midst of the COVID pandemic. Both our daily personal and business is currently being conducted through digital platforms. Platforms that are connected through networks that run through data centers. Data centers that are buzzing to keep the economy going. In fact, during these times, if your business is not on a digital platform, you're pretty much shuttered. This is all being made possible because of multiple technologies that have been converging together in recent times. Technologies such as cloud computing, IoT, 5G, artificial intelligence. In fact, we are living in a world where everything will be connected if it is not already connected. Connectivity that will continue to scale in terms of speed, bandwidth, and latency. All of these technologies will bring new experiences and business possibilities. From connected cars to augmented reality to industrial IoT, the possibilities are endless. One thing, however, is very clear. All of this data will have to run through data centers. Data centers at the back end forming the core, running the control plane, or data centers at the edge delivering the user experiences. In fact, in a recent survey done at Huawei, facilities are expected to double their footprint from 12 gigawatt in 2019 to almost 24 gigawatt by 2025. With this huge footprint of data centers, operating these data centers will become a gargantuan task. Now, it takes typically 2 to 3 years to build a greenfield data center, from planning to site selection, construction, and typically these facilities have a 10 to 15 year life cycle before a major overhaul is required. What's interesting that if we were to look at the total cost of ownership of a data center facility, almost 80% is operational cost. A bulk of this is energy cost, close to 60%, and the balance in terms of materials and services. Now this 80% O&M cost definitely brings a reasonable entitlement to reduce the costs, both in terms of energy and O&M. Now, downtime in a data center business carries a substantial business and financial impact, thus puts stringent focus on facility maintenance practice, most of which involves human manpower. Facilities today have diverse technologies in play, from electrical, mechanical, HVAC, instrumentation, and thus require both experience and expertise to perform operations and maintenance. Daily, weekly, monthly manual inspections are a major part of the maintenance of a data center and operate as a preventive measure. Responses are then driven through alarms, which make scheduled maintenance a passive response. In fact, multiple studies on data center accidents have demonstrated that 70% of these occurrences had their root cause in human error. Another area of concern is the typical gap in design versus actual performance within a data center, from PUE to utilization efficiency of resources. Now, Huawei has been investing in machine learning and AI technologies over the last many years. And in fact, currently, Huawei offers machine learning and AI stacks across many applications, from chipsets to machine learning as a service platform. Since 2016, we've been working on leveraging some of these ML and AI technologies to execute operations in the data center facility. Like many machine learning approaches, the application requires model training and then inferences that are then driven for execution on the active equipment. The focus has been mainly on digital maintenance, intelligent operations, and resource optimization. With everything connected, we have access to a continuous stream of data across all areas of the data center facility, from incomers to diesels, UPSs, chillers, air handlers, transformers, temperatures across bus bars, battery impedances, and so on. All of this data is then run through algorithms to generate a pattern which helps us to provide insight on usage, on efficiency, on health, on fatigue, deterioration, and in fact, tending towards a true data-driven insight and autonomous decision-making. A true lights-out data center is no longer an aspiration, but a clear possibility. At Huawei, we've been also working to put together guidance and benchmarking on the levels of automation management across multiple areas of IT operation. Here is a look at an AI-enabled autonomous management from L0 to an L5, a fully autonomous lights-out data center. Currently, we believe that there are data center facilities at L3 stage and soon approaching L4, wherein predictive maintenance replaces preventive maintenance. Predictive maintenance ensures continual optimization of energy efficiency and insight-driven recommendations to drive decision-making. So, how are we doing it? Well, the NetEco 6000 platform serves to offer digital visualization, predictive maintenance, energy optimization recommendations, and efficient resource utilization guidance. Now, it's very obvious that most of the PUE weightage comes from the cooling load. While most of the cooling elements have variable speed compressors, pumps, fans, the cooling system as a whole surely has an efficiency entitlement. As IT load changes by the hour in the data center, so does the weather outside through the day, the month, the year. It's very important to find the best operating point within the cooling system at which we can get the best possible PUE. The goal is to then continuously look for this most optimized operating point and operate the system to deliver the energy savings. Huawei has developed iCooling, which collects data points, filters them through data governance filters to a trained AI model, which then calculates the best operating parameters for the best possible result and releases this to the local system through an inference platform. With iCooling running 24/7, we've been able to reduce annualized PUE by 8 to 15%. Obviously, different geographies bring different PUE entitlements. Huawei worked on a case with China Mobile Data Center, about 15 megawatt of IT load, and we were able to bring down the PUE by about 8%. This was mainly driven by a 10% decrease in chiller energy and about 19% decrease in the crack energy consumption. Now for O&M, we've been leveraging machine learning and AI for inspection using image recognition, voice recognition, electronic sniffers. The ability to use cameras, microphones, and sniffers pretty much conduct all monitoring and now inspection can help us to manage the facility remotely. This unattended remote inspection allows us to reduce the manpower workload by almost 90%. This case becomes even stronger once you have dozens, if not hundreds, of edge data center sites spread across urban terrain. The availability of electrical systems is paramount in the data center. And unlike nuclear submarines, which come back to base for maintenance shutdowns, data centers have to run continuously without shutdown, with no compromise on the availability. This calls for an ability to predict the faults on the electrical system. With embedded IoT, there's a lot of data available, from bus bars, transformer cores, to battery impedances. All of this data can be reasoned using machine learning models to provide active insight. These analytics help them to predict potential issues and allow a maintenance model to transform from preventive maintenance to predictive maintenance. With data center capex running into tens of millions of dollars, it's critical for businesses to maximize capacity and resource utilization. Resource utilization is actually step one in this journey that still requires best practice rules to drive utilization while maintaining availability. AI-enabled engines can analyze the data from various dimensions, including network power, cooling, space, even weight of a cabinet, and provide intelligent recommendations. Leveraging of AI for resource management has been proven to improve capacity utilization by almost 20%, leading to a better return on investment. To summarize, the goal of AI is to maximize the total value of ownership. NetEco now has been installed across many data center facilities globally. Annualized data from one of these sites that runs Huawei's cloud hosting about 8 megawatt, 1,000 racks has been very encouraging. O&M labor hours were down by 20%. Timely O&M completion rate improved to 100%. Root cause analysis time dropped by almost 60%. I believe we are in the category L4 of autonomous data centers, working towards L5 in the near future. Thank you for your time and hope you had an interesting session. Have a great day.